right, video 2. Probably should have been video 1. So today we're going to talk about why a 1% drop in oxygen equals 50,000 parts per million. And so we're going to use a whole bunch of firefighter math here, okay? So the first thing we need to understand is that our atmosphere has 1 million parts per million in it. It's really important that we understand that. In our atmosphere, we have nitrogen, oxygen, and other stuff. In metering for oxygen, what we need to understand is that we don't meter just for oxygen. We have to account for the entire molecule of air. And why that is because our sensor doesn't have the ability to fracture off oxygen from that molecule of air. So, like I said, we cannot meter just oxygen. We must account for the entire molecule of air. So in a molecule of air, we're going to round these numbers out. So roughly, nitrogen is 70% of that molecule. Oxygen is 20%, and 10% of that molecule is going to be other stuff. So we're going to use some fractions here and some real rough numbers. Oxygen, like I said, it's 20%. 20% of 100% is 1/5 of a molecule of air. The remainder of air, the nitrogen and the other stuff, is 4/5 of that molecule. Add them together, 1/5 plus 4/5, 5/5, or 100%. Remember that 100% is going to be 1 million parts per million. So we're going to take these fractions and convert them back to the percentages. So 20% of oxygen is 1/5 of a molecule of air. That leaves 80% of that remainder of that molecule as other stuff. Add the two together and you get 100%. Excuse me. So we're going to determine what a 1% drop in oxygen is. So using these two columns right here, the oxygen and the rest of the molecule of air column, we're going to minus 1% right here. Well, because we cannot read just oxygen, we have to account for the remainder of the molecule. So if we're taking 1% from here, since it's 1/5, we have to account for 4% over here to total the 5/5 of change. So a 1% change in oxygen, that leaves 19% oxygen. So we're going to minus 4% from 80%, and that's going to leave us 76%. We add these two numbers up together, and now we don't get 100%. We're only at 95%. We have 5% missing. Well, what we're going to do is we're going to take that 5%, and we're going to remember that our atmosphere has 1 million parts per million. So real quick, we're just going to take 5% times 1 million parts per million, and we're going to get 50,000 parts per million. So 1% change in oxygen is equal to 50,000 parts per million. And that's how that's done.